Voila. You guys are like really giggly today. Okay, is this enough light? Are you guys over there? Is it too bright over there? Or is it okay? It's fine? Okay. Okay, so ladies, the feedback that I got from the other AP Pre-Cal block is that you guys have a lot of experience with quadratics from Algebra 2. Is that how you guys feel as well? Yeah. Yes. I'm hearing mostly yes and like 1 or 2 no's. Okay. So we're going to start, ladies. Shh. We're going to start out with a bunch of vocab, and then we'll go into some practice problems. Your homework gives a larger variety of practice problems, but I just kind of gave a sampling. The power function. Any function that can be written in this form, where a k and a are non-zero constants, is a power function. The constant a is the power, and k is the constant of variation or constant of proportion. You guys okay? Okay. We say that f of x varies as the 8th power of x, or f of x is proportional to the 8th power of x. This is one of those things where, just in case you get a problem on the AP exam that's worded kind of like this, you know what they're talking about. But hopefully if they talk about the constant of variation or constant of proportion, they also actually give you the function. All right, monomial function. Any function that can be written in this form, where k is a constant and n is a positive integer. This is a monomial function. A polynomial function, please let me know if I'm going too fast, okay? A polynomial function, let n be a non-negative integer, and let all these lovely a's be real numbers with a sub n not equal to 0. The function given by this thing is a polynomial function of degree n. The leading coefficient is a sub n. All right, so the big thing you need to notice here is that if you have a polynomial, polynomials can have degrees of whatever. It could be a quadratic, it could be a cubic, it could be a quartic, it could have a degree of 10 or 20 or 50 or whatever. If the powers are written in descending order, that first term, your leading term, that's going to show your degree and your leading coefficient. The degree and the leading coefficient can be used to determine a lot of stuff about the graph. Polynomial functions of no and low degree, the 0 function, f of x equals 0, the degree is undefined. The constant function, that's where you have y equals some number, like y equals 5, it's just a horizontal line, that has a degree of 0. Linear function has a degree of 1, a quadratic function has a degree of 2. A linear function is a polynomial function of degree 1 and has this form, also commonly referred to as y equals mx plus b. A and b are constants, and a does not equal 0. Vertical lines are not graphs of functions because they fail the vertical line test, and horizontal lines are graphs of the 0 function or constant functions. All right, quadratic functions. A quadratic function is a polynomial function of degree 2. The standard form of its equation is this. Any quadratic function can be written in vertex form, which looks like this. Are you guys all familiar with standard form and vertex form? You guys have seen this? Okay. Standard form comes in handy if you're trying to use like the quadratic formula. Vertex form is more useful if you're trying to graph it because you can more easily see the vertex. The graph of f is a parabola with vertex hk and axis of symmetry x equals h, where h equals negative b over 2a. If a is positive, the parabola is concave up. If a is negative, it is concave down. And here is what it would look like. So this would be a concave up parabola, this would be a concave down parabola, and the axis of symmetry would be x equals b over 2a, negative b over 2a. Example number 1. Which of the following are polynomial functions? For those that are polynomial functions, state the degree and leading coefficients. For those that are not, explain why not. All right. If I was to just ask you to tell me yes or no, are these polynomial functions, do you guys think you could do that for these 4 problems? Okay, use the definition of polynomials. Because they're yes, no, you'll only have 1 chance to answer, so make sure everyone at your table agrees before you hold up your whiteboard. Maybe they are. We'll find out.
Right, so the first one, the degree is 3. So the first one, the degree is 3. Yeah, they're all. Where's the answer?
So you're giving me A, B, C, and D. So ladies, you're just giving me number 1, so A, B, C, D, yes or no. Just give me yes or no for each one. You don't need to give me the degrees, the leading coefficients, the reasons, none of that. Just give me yes or no for A, B, C, and D. I just told you to put away food and drinks. Thank you. All right, I'm going to give you guys 90 seconds more, and then we'll go over it. Okay. I'll tell you at the end. I'll tell you in 1 minute and 10 seconds. All right, you guys have about 1 more minute. About 1 more minute. Okay. I'll tell you in a moment.
Oh, we only have 1 try.
Team 1, did you say yes, yes, no, yes, or yes, no, yes, yes?
Yes, yes, no, yes.
Thank you. Okay.
No, it's just
Thank you. All right, teams 5 and 6. Okay. All right, everyone has answered. The answers are yes, no, no, yes. Congrats to team 4 who got them all. All right, let's go through these. Okay. Darn. Okay, for A, I'll give a bonus point if someone can raise their hand and give me the degree and the leading coefficient. Go ahead, Aurelia.
degree is 3 and the leading coefficient is 4.
Perfect. Degree is 3, leading coefficient is 4. All right. B, the answer is no. I'll give a bonus point if someone can raise their hand and tell me why. Go ahead, Cora. The exponent, yeah, so the exponent is negative. You can't have a negative exponent in a polynomial. Great job. All right, for number 3, who can tell me why this one is no? I'll give priority to team 4. I think they're the only ones who got this one. No, team 1 also got this one. Team 1 or 4. Anyone from teams 1 and 4?
It's the square root.
I'll take it. All right. So h is not a polynomial because of the power of 1/2. Remember, square root is like a power of 1/2, and because it can't be simplified into polynomial form. So the square root would have been fine if it simplified into polynomial form, but in this case it does not. Nope. Nope. Because of the addition sign. You would have to factor it, and this doesn't factor it. If it was 9x squared times 16, yeah, or divided by, then it would be fine. All right, this one is also yes. Bonus point if someone can tell me why. Go ahead.
A y or the leading coefficient?
The leading coefficient and the degree, yes.
Okay, the degree is 4 and the leading coefficient is -2.
Perfect.
I would have said 1 and 15, but that would have been embarrassing.
All right, are there any questions on any of these? So this comes in handy if you get a test question that says, suppose f is a polynomial function. Already that cancels out a whole bunch of things that f can't be. All right. Does anyone need a few more seconds to copy this down, or does anyone need me to backtrack a little bit? Yes. Oh, because of the square root. No, so square root, anything that is the square root of something, that's like raised to the 1/2 power. So this would be like 9x to the 4th plus 16x squared to the 1/2 power. And what's inside, you can't factor it. Any other questions? Yes. Yes, I can. How far up? Right here? Okay. Okay.
For letter C, what does the power have to do with it? Like, is that one of the rules?
So, yeah. Let me go back to the definition. So if you look under polynomial function, where am I looking? Oh, okay. So monomial functions, n has to be a positive integer.
But wouldn't it be like 1/2 and that's still positive?
It's not an integer.
Oh,
So fractions are not integers.
sorry.
All good. So yeah, this one's negative, so it's not a positive integer, and this one's 1/2, so all good. It's okay. All right. Anyone need more time? Okay, I'm gonna go to the back, or rather the next page. Where's my cursor? There it is. Okay, so example number 2 says write an equation for the linear function such that f of -1 is 2, f of 3 is -2, which means that these 2 points make up the function. Do you guys all remember how to come up with the equation of a line between 2 points? From Algebra 1? Yeah, we're learning this next unit in Algebra 1. Yeah. Well, hold on. Yes. That's the slope. So the first step would be to find the slope, and then you have to plug it in, solve for b. You guys remember how to do this? Okay. Go ahead and solve for the equation of the line. When you have it, please hold up your board. Yes. You guys are finding the equation of the line. The equation of the line. Nope, sorry. I'm going to give you guys one more minute. Is that enough? The slope is correct, yes. I usually use y equals mx plus b. I plug stuff in and solve for b. Well, you plug in x, y, and m. You can also use point slope form. It's not right, but the slope is correct.
3 minus negative 1 turns into.
Yes, good job. Yes, yes. Erase the 1 on the x, though. Yes. The slope is correct, but it's not correct. You shouldn't put the 1 there. Negative x. Negative 1 is the slope. The slope is correct. All right, anyone else have an answer? Yes. All right, ladies, here is the answer. So I think everyone successfully found the slope. The slope is going to be negative 1. Then usually what you would want to do is plug stuff in and solve for b. You could also use point slope form. That's y2 minus y1 equals m times x2 minus x1. That also works. This is the way that I prefer to do it. So I plugged in x and y, I plugged in m, and I solved for b. I got b equals 1. Once I have m and b, I can just plug that in. I get y equals negative x plus 1. And here is the graph. All right, looking at example number 3, it says use the vertex form of a quadratic function to find the vertex and axis of symmetry, or just axis, of the graph of f of x equals 6x minus 3x squared minus 5. Rewrite the equation in vertex form, support your answers graphically. All right, do you guys feel comfortable converting from standard form to vertex form with a quadratic? It is not in vertex form. In fact, what you're given is not in standard form either. So you would first want to put it in standard form, and then you'd want to convert it to vertex form. Do you guys feel like you could do that? Vertex form is a quantity x minus h squared plus k, where hk is the vertex. It's on the previous page with all the equations. And there's a formula where you can use a and b to find h. And then you plug h in to find k. Okay, hold on. It seems like people know how to do this. Do you guys want to give it a try? People are already holding up boards. Go ahead and give it a try. Please give me vertex form of this equation. All right, I'll give you guys 2 minutes, and then I'll check in. Are you guys, like, really lost?
Yes.
We could go over it. When I was asking, some people started holding up boards, so I thought maybe you had it. But now I'm hearing bits and pieces of conversation that you don't have it. What would you like? You want to continue, or should we just go over it?
Go over it.
So that's standard form. You're almost done? It is really close. You forgot your A. Throw in your A. That's not right, sorry. Let's just let the time run out. If anyone gets it in the next minute and 15 seconds, I'll give you the point, and then we'll just go over it. If you're really lost, just hang out for a minute, and then we'll go over it. Team 2, don't start over. You just have the incorrect A. A is the same between standard form and vertex form. A is the same between standard form and vertex form. Yep.
I thought it was negative b over 2a.
That's H. It's not right, sorry. Yes, that's right. There's a formula on the front of the page. Yes. It's not right, sorry. So on the front it says H equals negative B over 2A. Negative B over 2A, yeah. All right. If you didn't get it, that is perfectly fine. We're going to go over it. No, sorry. Did everyone convert this to standard form?
Yes.
Yeah? Okay. So you want to make sure your x squared is out in front, then your x term, and then your constant. We want to make this look like this. The way you want to do this is you want to use the formula H equals negative B over 2A. And this is on the front of the page, the first page of the notes of this section. So plug in B, plug in A, we get 1. So now we know that the x term of our vertex is 1. The way that you find the y term is you plug in 1 for x and see what you get for y. That's going to be your k. So when I plug in 1 and solve, I get k equals negative 2. So now this has to be vertex form. I've got f of x equals a, my a is negative 3, h, my h is 1, k, my k is negative 2. And notice that it's minus h, so this one is the only one whose sign is going to change in the equation. Yes? Oh, because I found out that h is 1, and so whatever h is, that's what you use to find k. All right. Does it make sense? Are there any questions? That was a really good explanation. Did it make sense, Lydia? Okay, so we know that this is the x-coordinate of the vertex, right?
Yes.
With any point, if you know what your x is, you can find your y by plugging in x and solving. In whatever form, doesn't matter.
Okay.
We have standard form, so that's what I used.
Okay.
All right, and then here's the graph with the vertex and the axis. Okay, so the next part of the notes, we're going to be using your calculators. We're going to be talking about residuals. Okay, so little disclaimer here. Residuals, this is one of those topics that when all the pre-calculus teachers discovered this was going to be on the AP exam a few years ago, we were all a little bit confused because it's kind of an obscure topic in pre-cal. If this does appear on the AP exam, I would guess that it would be a multiple choice question, maybe 2 multiple choice questions on the graphing portion. If it appears on, not the graph portion, the calculator portion. If it appears on the non-calculated portion, they would have to provide you with a chart. Otherwise, it would be impossible to solve for these. Is anyone in here taking AP Stats? Yeah, okay. So you might already know some of this stuff already. You do a lot more with residuals and regression in stats than in pre-cal. We're going to be learning very basic information about residuals. So a definition here, regression and residual analysis. We have explored the concept of linear and quadratic regression and certain other regression models. Suppose the model data set, this using the function y equals f of x. then residual is the difference between the actual observed y value and the data set corresponding in the data set and the corresponding y value predicted by the model. So what that means is when we have some data in a chart and you guys create a scatter plot for that, and then you come up with some regression model based on that data. Okay? The equation doesn't always hit all the points. In fact, usually it doesn't hit all the points. So the model value and the actual data point value, there is a difference. That difference can be charted using a residual. So residual is the actual value minus the model value. Your y minus your whatever your function is producing. So we can create a set of residuals by just finding the difference of everything. And we're going to use the calculator to do this. The linear regression line is called the least squares line because it minimizes the sum of the squares of the residuals. If we construct a square for each of the points in figure 11, over here, the linear regression line will have the smallest possible sum for the areas of the squares. So what that means is when you calculate a linear regression using your calculator, what your calculator is doing is it's taking all of the given points, and it's taking all of the points that appear on the linear function, subtracting and squaring the value, squaring the difference. And then it's adding all of those squared values together. Whatever equation produces the smallest sum of the squares, that's the equation it gives you as your linear regression. That's how the calculator calculates that. In this class, we will not be doing that by hand. We will only be doing that with a calculator, but that's how it's basically calculated. All right, so how do we do a residual? Go ahead and take out your calculator. For this example, I'm just going to use the values that are here. You can use whatever values you want. So please turn stat plot on. If it's not already on. And also turn on stat diagnostics. Stat diagnostics can be found in mode. The default is off. If you have a regular TI-84 Plus, you'll have to scroll down past the screen. It doesn't appear on the initial screen, but if you keep scrolling, it should be there. Mode. And then you want to turn stat diagnostics on. Stat diagnostics is here if you have the CE. If you have the regular TI-84 Plus, just keep scrolling past the screen and you'll see it eventually. Yes? Oh, go second, y equals, and then plot 1 should be on. Sorry? You don't want to turn them all on, just the first one. Oh, then turn 1 on. Just hit enter and then highlight on and hit enter. All right, once you have all that done, please go to Stat. Stat is right here. And then go to Edit. And I'm just going to plug in these values. I've got 1, 3, 4, 7, 8, and 12. 8, 9, 14, 19, 22, and 21. So there are my values. I just copied this chart here. Yes. That's because you haven't calculated the linear regression yet. You first have to calculate a regression model, and then it will give you the option for a residual. All right, do you guys need a little bit more time to type in the values? Okay, so from here, what you want to do, go back to Stat, go to Calc, and calculate a linear regression model. That's number 4. You don't need to create an equation with y1. Ta-da! No? Okay. Can you guys help her out? Can I help? Did you put in your chart?
I tried to, like,
Go to Stat and Edit. So go to Stat and Edit, number 1. There you go. Put in the values there. Well, you need to delete all that.
No, but I was entering it.
Okay, so just type it in there.
Oh, what is that?
Can I just reset your calculator?
Sure. Like, that's what it was, like, showing up.
Yeah, if it's giving you weird stuff, just reset it.
Okay.
Let's see here.
And also, I don't know if that, but like, that just, like, showed, I don't know if that's, like, something,
Training stat diagnostics on for you. This one?
yeah.
I don't know. I'm not sure. Okay, it should be fine now.
Okay.
There you go.
Thank you.
Sure. All right. Are you guys ready for the next step, or should I wait another minute while you guys get to this step? Maybe wait one more minute? Okay. All right. For those of you who are done, if you want, you could just graph the regular scatter plot. You could graph zoom 9, and that'll give you the regular scatter plot. Oh, you have something in y equals. Yeah, if you hit graph zoom 9, you should end up with this scatter plot. All right. So this is not the residual model. There's one more step you need to do to get the residual. So what you want to do is you want to go back to stat plot, hit number 1. Where it says X list, we should have L1. Where it says Y list, this is where you're going to want to delete L2 and put residual instead. So if you hit clear, and then you want to go to this blue list thing. So you're going to hit second and then stat. Residual should be at the bottom. Looks like it's number 8 for me. So it should be L1 and resid. Yes. So delete or clear L2, and then you want to get this blue list. So hit second, stat, residuals number 8. If it's number 7 for you, that's fine. If it doesn't appear for you, it's because you didn't calculate the linear regression yet. You have to calculate the linear regression first. Or some kind of regression. All right, so now when you graph and hit zoom 9, you'll get this. This is a residual. Yay. Yes?
When I go to second stat, like before the residual, my only goes to 6. And I try spelling that.
Did you calculate the linear regression model?
Oh, is that a second stat?
Yeah, so you have to calculate linear regression, otherwise the calculator can't calculate the residual. Mention mismatch. This happened to a few people in block C. I'm trying to remember what we did. Did you calculate the linear regression? I'm just going to calculate it again real quick. Okay, I think that was it. I think you have 2 scatter plots going. Oh, you have 2 stat plots. You have 3 stat plots. I'm turning them off. That might have been the reason. Here you go. All right. Any questions on the basic procedure on how to get the residual? Okay. I'm now going to talk about one way, ladies, shh. I'm now going to talk about one way that you might use residuals. We're not actually going to make all these residuals. I'm just going to show you what they look like. If you were to put this data set into your calculator, you would get this scatter plot, this linear regression model, and this residual. Notice that the R and R squared are like exactly the same as all the rest. So this is data set B, this is data set C, and this is data set D. Okay? In every situation, R and R squared is very, very close together. So we have a situation where we're not really sure which regression model is best because all of our R's and R squareds are about the same. If you are trying to figure out which regression model would be best, but all of your R's and R squareds are very similar, you can use a residual to figure this out instead. So data set A, a residual will ideally show a shotgun look. Basically, that's a random spread. If that's what you have in a residual, that is a good model that you're using. Data set B is not valid, or the residual plot is not valid because it shows a definite pattern. If your residual shows a definite pattern of any kind, the model that you're using is not a good model for that data set. Data set C, also a definite pattern. We have an outlier, though we can already see that on the regular scatter plot. Data set D also shows a definite pattern, and it doesn't show us anything we couldn't already see in the original data. So in this case, if you were asked a question about which of these models would best represent the data set, the answer would be A, because the residual shows a shotgun look, a random spread. Okay, we're going to make just one more residual, and I made a little mistake here. I didn't mean to give you guys the equations. I wanted you guys to find the equations, but oh well. When you're putting these into your calculator, you're only going to use the first 2 columns. So only the first 2 columns. And notice it's the same for both, so you just have to put it in once. So stat, edit. In order to delete the whole column, you can hit clear enter. Clear enter.
How do I get it to see residual? Am I on the
Oh,
right thing or not?
you're in the wrong place. So what you want to do, go to the second stat plot, this one, turn it on, and then where it says L2, this is where you're going to hit clear, second list, and there you go. And did you already calculate the linear regression?
No.
If you didn't, it's going to give you an error. Yeah, measure mismatch. So what you want to do is stat calc linear regression is 4. There you go. Now go back here, graph, zoom 9. Okay, here you go. Thank you. Sure. Do you guys need another minute to type in the data? Okay, you got it. That is the regular scatter plot. So here, let me, if you change this back to L2, graph, zoom 9, so that's going to be the regular scatter plot. Okay, do you guys need more time plugging in the values, or are you guys ready for the next step? 2 more seconds. Someone was asking about the regular scatter plot. This is the regular scatter plot. We're not going to use this one. So this is where we are. Yes?
Where do you get 1.045 for the equation?
So ignore the equation. I didn't mean to give you guys that. I wanted you guys to find the equation. I will make that change for next year's notes. All right, so from here, in this case, notice we're using a quadratic regression model. So you're going to go back to Stat, go to Calc, and quadratic regression is number 5. No need to calculate the y1, vars, y vars, so just hit calculate. All right, once you've calculated a regression model, now you can go back. And if you change this back temporarily, make this residual. So second stat residual is number 8 for me. Too fast? Okay. So this is second y equals plot 1. Do you need help, Lydia? Hold on. Is everyone okay? Is everyone here? Do you need help? So your L2, you need to delete that. Hit clear.
Wait, I thought I had to change it to L2.
Nope. So then you're going to hit second stat, and you want it to say residual. So for me, that's number 8. But residual will only appear if you've already calculated a regression model. Otherwise, it either won't appear or it will give you an error. Are you good?
Yes.
Okay. All right, so now when we hit graph and zoom 9, we get what looks like a nice random spread. Okay, you didn't calculate the quadratic regression.
Oh, I did I did not do that one. I did the.
Did you do
the one that we did before?
the linear regression? Okay, calculate quadratic regression and then go back and graph it again. Okay, listen, ladies, if you're getting an error, pay attention. This is the step that you missed. Hit stat, hit calc. Quadratic regression is number 5. Hit calculate. You must do that, otherwise when you try to find the residual, it'll give you a mismatch error. If you find some other regression model, like linear regression, it's going to give you a different residual. Okay? Did that make sense? Quadratic regression. For this one, we're doing quadratic. Yes? Did you do a quadratic regression or a linear regression? You did a quadratic regression? Did you change this to resid? And it's still giving you something different. Can I see your calculator? Yeah. Is yours the same as mine?
It rounds a lot of them.
Oh, some of your numbers are different. Like your first two. You have 1.04.
Okay.
That's the
the
reason.
ones that side. Maybe I accidentally put the okay.
It's all good. All good. All right, so ladies, we're almost done. Did everyone get the residual for the quadratic?
Yes.
Is there anyone who's still kind of confused? Okay, now we're going to do everything over again. Leave the data in the table. You don't need to retype it. But now we're going to do a linear regression. So what you do is stat calc linear regression is number 4. Calculate, and it will give you some stuff for linear. Yes.
Why does my scatter phone?
Hit zoom 9.
Is it 4? Oh, okay.
All right. So now you hit graph, zoom 9, and you get what looks like a parabola. This is a definite pattern. So the linear model is not a good model for this data. It does not give a shotgun look. It does not give a random spread. It gives us a parabola. So, which one is a better model? The pattern in the residual seems random. It gives a shotgun look. Also, r squared is like really close to 1. So the fit's very good. This is a better model. Here, there's a clear pattern in the residual. R squared equals 5.1%. So the model only explains 5.1% of the variation, and 94.9% of the variation is left unexplained by the model. So this one wins. I'll zoom out a little bit so I can put both of them there. So the parabola is not a good model because it is a definite pattern. You want a shotgun look. You want a random spread for residuals. All right, and that is the end of the notes. Yes. Yes. So that is the end of the notes. Are there any questions? Yes.
How did you find the equation from
The equation?
You said that you would have to find it.
If you needed to, yeah. So what we did before when we found the linear regression or the quadratic regression, it gives you A, B, C, or just A and B. You just plug that in, and that's how you get these. Any other questions? Yes. I recommend trying both and seeing which one gives you a shotgun look. Yeah. Or use R squared. Any other questions? All right, I'm going to leave this up here. I will also post the notes so that you can copy them later if you need to. And you guys have the rest of the block to work on homework. I'm available for questions if you have them.